Hi, I'm Geof Hall from the Beaty Water Research Center at Queen's University, and welcome to the first of our water talks. We're going to be talking about water issues from water quality to water flows through the natural environment, and we'll talk about social water. I'm fortunate that here in my home we have water resources that we can talk about. So we'll be practicing physical distancing, and we'll be exploring water in a fun and exciting way. Right about now, we'd be gearing up for our educational offerings in the field and our outreach programs. Well, we can't do that. We have to be creative in these times. So, we'll be covering some educational videos on these different aspects of water. So, we're standing next to a small creek in Eastern Ontario, and normally we would throw a water quality probe in or other instrument to look at that. Well, we can't do that right now, but there's a lot we can figure out just by looking at the creek. So, I'm going to throw this camera in, and we'll go down and we'll explore what's going on. The first video in this series is going to talk about water clarity. Why is it important? What does it do for us? And what do we need to worry about? So let's throw this camera in and see what we can see. So as we put the camera into the water, one of the first things we see is that it's cloudy. We can't see very well through the water. And that is a phenomenon called turbidity. And something that I would like to cover in this water talk. I'm going to move the camera around into different spots in the stream so we can just see the effect of that. But what is turbidity? Well, it's a measure of the clarity of the water. And that becomes really important whether we're talking about natural systems or water for source for drinking water and so forth. So what's causing this turbidity or this cloudiness of the water? There are a number of things that are contributing to this, but essentially we're looking at particles that are in the water that are being carried downstream. Now, we had a very heavy rain in the past couple of days, so we're seeing a lot of particles that were taken off the surrounding landscape and into this stream. What are those particles? Well, clay. Clay is a very common part of what makes up turbidity, but basically any inorganic and organic matter that's being carried in the water can contribute to turbidity. In addition, any microscopic organisms that are in the water will increase the turbidity of the water, as well as some dissolved compounds that have colors in them. So why is it important though? What does turbidity really do in a natural system and to drinking water? Well, there are a number of impacts that it has. First of all, it can increase sedimentation within a river. So that's going to have a carry-on effect of increasing the sediments and materials that are being deposited on the bottom of the river or stream, and consequently the lake or larger system that it's flowing into. Now, this can also have an effect if there are fish spawning in the area. Any eggs that are laid in a river or stream system, a lot of the times they need clear water and lots of oxygen. While if we have materials settling on top of those, they can actually have a detrimental impact on the eggs. If we have a situation where there is high turbidity, then the light also can't penetrate down as far as it normally would. So that can affect the growth of aquatic plants and so forth. But one of the really important aspects around turbidity is the impact on human health. If we have particles in the water in the form of turbidity, they can also be a hiding place for bacteria and other pathogens. So if we're going to be using this water for a number of purposes, from drinking water to irrigation and so forth, we may be concerned about the fact that these particles in the water are hiding the organisms from any treatment that we may want to put on the water. As you can imagine, if we were to use an ultraviolet sterilization system, the ultraviolet light would have a hard time penetrating through that cloudiness to disinfect the organisms. And the same would be true if we were to use something like chlorine. The chlorine would effectively be used up in reactions with the particles themselves and may not address all of the pathogens that are there. So how do we measure turbidity? Well, there are a number of different ways. One of the common methods that's used in the field is what's called a Secchi depth. Essentially, it is a disc that is lowered down into the water column to the point where you can't see it, brought back again, and that will give you a measure of how clear the water is. We can also take a measurement of the optical clarity of the water. That's an NTU measurement, nephelometric turbidity unit. All of these are basically, though, giving us a proxy for how clear the water is, which is giving us an indication of the level of particles in the water. Now, the one thing that you probably have noticed is that there's a lot of bubbles in the water. The water's flowing across rocks, it's creating a lot of turbulence, And that brings us to the topic of our next discussion, which will be dissolved oxygen. So just keep that in mind. So thank you very much for joining me for our first water talk. I hope to see you again soon.